Alright, hey guys, this is Mr. Walker here, and I am doing a review lesson over 4.3 that use models to multiply a decimal and a whole number. Then I'm also going to go into using a grid, kind of like we did in 4.5, at the end to kind of give you a preface of what's to come and when we review 4.5. So let's just go ahead and get started with 4.3. You know, multiplication can be represented by using repeated addition. We know that. So they gave us an example here, 5 times 42 hundredths. Really all you're doing is you're adding 42 hundredths 5 times. So here they've got 42 hundredths plus 42 hundredths plus 42 hundredths plus 42 hundredths plus 42 hundredths. If you were to add these together and line them up with the decimal, then you would be able to get your product. But no one really wants to add 42 hundredths 5 times. No one really wants to do that. I mean, that takes time, and it's easier just to know your multiplication facts and just multiply them. So I got to change my color here before I start writing because I'm on a different color screen. So it says which numbers get added repeatedly. Well, obviously we can see by the example that 42 hundredths gets added repeatedly. And then it says which number tells you how many times of that number to add. Well, if you look, it says 5 times, hello, hint hint, wink wink, 5 times 42 hundredths. So the 5 tells us how many times to add. And so when you do that, I'm going to line them up down here at the bottom, and I'm going to add for you just to show you the repeated addition. I'm probably going to have to write small, so forgive me. But if I've got 0.42, my decimals are getting off because my computer screen. And I were to add all of these, and we know there's a 0 in front of that decimal. But we can count by 2s here on the ones in the hundredths place. 2, 4, 6, 8, 10. Well, if it's 10, I know I'm going to have to regroup. I drop my 0, I carry my 1. 1, 2, 3, 4, 5. Well, there's 5 4s, so I know 4 times 5 is 20, plus 1 is 21. Now here's the thing. If we were to pretend that this was a whole number, and we were multiplying, we would have to count how many places to the right we move our decimal. But in this case, we can just bring our decimal straight down, which is really 2.1. I put my 1 a little bit too close. Let me erase this. Okay, so my answer is 2.1. Now, if I were to do this the standard algorithm way, I would say 0.42 times 5. And then I can pretend that this is a whole number, so I'll move it 2 places to the right. That's something I need to remember, so that way I can move it 2 places to the left when I'm finished. 5 times 2 is 10. Drop my 0, carry my 1. 5 times 4 is 20, plus 1 is 21. And I know my decimal is here because I've got a whole number, so I've got to move it back to where it was 2 places. So my answer is 2 1/10, or 2 10 hundredths. But we know that 10 hundredths equal 1/10. So my answer is 2.1. Okay? Let's keep going. So it says estimate here. Estimate 2 times 54 hundredths. So rounding to the nearest tenth, that's this number right here, this 5. I'm going to look at the 4. That 4 tells me that that 5 is going to stay the same. So it's going to be 0.5. Okay? Now, 2 times 0.5. Well, that means I can either add 0.5 2 times if I'm doing repeated addition. And I know that 5 plus 5 is 10, but this would really be 0.10. It would be 0.1. No, it wouldn't. That's wrong. Excuse me. You just love my videos because teachers make mistakes, and I'm one of those teachers that makes tons of mistakes, usually all the time. 0.5 plus 0.5 is 1.0, so it's a whole. Okay, so right here we can just write 1.0. We have 0 tenths and 1 whole. If I were to multiply this, I would say 0.5 times 2. I'm pretending this is a whole number, so I'll move it one place to the right. 2 times 5 is 10. Drop my 0, carry my 1. 2 times 0 is 0, plus 1 is 1. Well, because I moved it one place to the right, I got to move it one place back to the left. So my answer is 1.0. Okay. So this one says, sketch or use place value blocks to model 2 times 5400ths using repeated addition. So just as a recap, we know that this is called, we call it a flat. It's a square, but we call it a flat, and we know that this equals 1 whole. A line or a rectangle equals a tenth, and then a little dot equals 100th. So it wants us to model this. So if I look at the number 5400ths, I know that I'm going to have 5 tenths, because it's in the tenths place. So I know I'm going to have 5. 1, 2, 3, 4, 5. I'm going to have 4 hundredths. 1, 2, 3, 4. And I've got to add it 2 times. 1, 2, 3, 4, 5. 1, 2, 3, 4. So here I can see, and I want to start with my hundredths always, furthest place from the decimal. 4 and 4 is 8. 1, 2, 3, 4. 5, 6, 7, 8. So I know that there's going to be 8 hundredths total. And then 5 and 5 is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now remember, 10 tenths equal 1 whole. So really, this is 1 whole point, and I have how many hundredths here? Well, it's not 4. See, making mistakes again. 1, 2, 3, 4, 5, 6, 7, 8. It's 8. So I have 8 hundredths. And so just like I'm doing, I make mistakes, but, mistakes are proof that you're trying, and that's what I expect from you all. And, if you realize you get something wrong, go back and try to fix it. So my answer here would be 1.8. But it says 2 times 54 hundredths is the same as adding 54 how many times? 2. That's what we just did here. And we already kind of skipped ahead and we regrouped the blocks to get 1.8, because I know that this 5 here and this 5 here equal a whole. I don't have any tenths, and then I have 0 tenths. This is actually wrong. Whoops, see, look, there I go, making more mistakes. And then I have 8 hundredths. So really my answer is 1.08. Sorry, it's been a long day, guys, so just forgive my mistakes. I'll get you there, I promise, just be patient. Okay, so 1.08 is the product. I can always double check by doing the standard algorithm, which I encourage you to do. 54 hundredths, my pen's messing up. Oh, snap, crackle, and pop. My pen's messing up, so sorry. So I've got 54 hundredths times 2. 2 times 4 is 8. 2 times 5 is 10. Well, if I made this a whole number, that's 2 places to the right, so I've got to go 2 places to the left. So it's 1.08. My answers match. Okay? I know I'm going to go through a little bit faster just because I need to get done with these slides before my 15 minutes is up. But it asks, is my answer reasonable? So if I go back to this, how can I determine if my answer is reasonable? Well, I can round. You know what I didn't do here, and I just realized this, that I forgot before, but we were estimating. So here's my estimation, and I got 1.0, and I know if it's reasonable if it's close to 1.0. So or 1 whole and 0 tenths. But here I have 1 and 8 hundredths. So is my answer reasonable? Yes. My answer is reasonable because, why do you think? 1 whole, or 1.0, is close to 1.08. They're in range. Okay, so make sure when it says explain, you need to explain why. It can be short and sweet and to the point. All right. So this one says sketch place value blocks to model 3 times 62 hundredths and then write the product. Okay, so once again, my flats, my tenth sticks, as I call them, and then my hundredths. So I need 6 tenths, 1, 2, 3, 4, 5, 6, and then 2 hundredths, 1, 2. I'm going to do the same thing, and I'm adding them 3 times. 1, 2, 3, 4, 5, 6, 1, 2, plus 1, 2, 3, 4, 5, 6, 1, 2. So I've got my tenths and my hundredths, and I've added them 3 times because it's 3 times. So now remember, 10 tenths equal 1 whole. 10 hundredths equal 1 tenth. I told you that in a couple lessons ago. This is important to remember. I just ran over my 1. Forgive me. So let's count. So we've got we've got 6 here. So this would be 7, 8, 9, 10. So from here over, this is already 1 whole. Okay, so I know I've got 1 whole. And then I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 tenths left. So I've got 1 whole. 1, 2, 3, 4, 5, 6, 7, 8 tenths left. And then I've got 1, 2, 3, 4, 5, 6 hundredths. 1, 2, 3, 4, 5, 6. So my answer is 1 whole and, oh, I keep clicking my pen. I'm so sorry. Sometimes it does this. You can ask, if you're a parent watching this, you can ask the kids. I have trouble with this pen a lot. 1 and 8 hundredths, or excuse me, 8 tenths, right? 1, 2, 3, 4, 5, 6, 7, 8, and then 6 hundredths. So my product is 1 and 86 hundredths. Okay. All right, so this one is going to the shading part that I was talking about. That's going to prepare you for 4 or 5. So I'm going to get my highlighter out. And I'm going to use 2 different colors so you can see, but this is a hundreds grid. It's got 100 little squares in here. And it says a forest has an area of 1.3 square miles. So think back, we talked about an array. An array is where you have objects like triangles in a row and a column. So this would be a 2 by 3. I've got 2 columns and 3 rows. Rows go side to side, and columns go up and down. So I'm going to do 1 whole. Okay, so this whole thing would be shaded. Because that represents 1 whole. And then if I were smart and I had another grid over here, I would have added another grid. But I'm running out of time, so I'm trying to rush. But my other grid, I'm just going to draw it, and we're going to pretend that there are 100 little tiny cubes in here. I'm going to erase this so that way we can make it fit. Oh, I'm still on my eraser. So here's my other hundredths grid, and I need to go 3 tenths. So 1, 2, 3. And I'm starting with my columns. So there's 1, 2, and 3. Okay. And then it says 4 tenths of a mile of the forest is hiking only. Shade the model to determine the area. So the area is where it's going to be overlapped. So these are going to be my rows. 1, 2, 3, and 4. So I could count these boxes, you know, and it'd be in an inefficient way. But that's when I just start solving using the standard algorithm. So 1.3 times 0.4. 4 times 3 is 12. Drop my 2, carry my 1. 4 times 1 is 4, plus 1 is 5. If I made these whole numbers, 1 place to the right, 2 places to the right. So I've got to move it back to where it came from. 1, 2. So my area would be 52 hundredths. If I wrote it as a fraction, it would be 52 over 100. Okay? So I hope this helps you review 4.3.